Hello, good day everyone. This is Sir Franz, and in this part of this video, we're going to understand and solve examples on the third type of conic section, which is ellipse. So, allow me to start the presentation. So in this part, as you can see, we have an illustration here which indicates the illustration of the ellipse. Now, so to understand further, sir, what do we mean by these two illustrations? These two illustrations give us the idea to why the standard equation of an ellipse will be like that. Okay, it's because from the definition itself that an ellipse is just simply the sum of two lines from the fixed points, which is also the F1 and F2. So to understand further on that one, let me go on with this, that let F1 or F sub 1 and F sub 2 be two distinct points. The set of all points P whose distances from F1 and F2 add up to a certain constant is called an ellipse. The points F sub 1 and F sub 2 are called the foci of the ellipse. Given our 2 points of the x-axis, we have negative c0 and f sub 2 is c0. So that's based from the given. You can see it here, negative c0 and c0. The foci, which is the foci, both c units away from their center, which is the origin. If you're going to see the figure 1.220, this is the figure. And then let P be the point X and Y, be any point or be a point on the ellipse. Let the common sum of the distance be 2a, which is the coefficient 2 will make the computations simpler. Thus, we have the distance P to F1 plus P to F2 is simply equal to 2a. So we make use and derive this one. Okay, let's go back. This is the distance from P to F1, the distance of P to F2. So we are going to double check whether the definition of the ellipse is correct. It was mentioned that the sum of two distances from two fixed point to a point on the ellipse, 1 point on the ellipse, such that we have P here. If you're going to ask me, sir, can I choose any point on the ellipse? Yes, you can choose any point. So this is the point chosen in this illustration. So as you can see it here, this formula that we can see is the reason why we got the standard equation. No? So to understand that one, the standard equation is derived by the application of the distance formula. If you're going to check here the illustration of the ellipse, P going to F sub 1 is a distance. P going to F sub 2 is a distance also. So its sum of the distances is simply equal to 2a. Sir, is 2a there a constant? Yes, it will always be a constant value. So if you're going to proceed now with the derivation of the certain formula, so you can see it there that the point P to F sub 1 has the points x plus c quantity squared plus y squared, which is equal to 2a constant. The value of 2a is constant minus the the point of P to F sub 2 is the x minus c quantity squared plus y squared. So if you can check it here, sir, how did that happen? It's because of this illustration again. So if to double check that one, we can say that substituting all those points needed, knowing that the P is the X and Y, and then the F sub 1 is the negative C and 0, the F sub 2 is C 0. So we are going to expand here which is inside the radical symbol. And expanding that, we get x squared plus 2cx plus c squared, copy the y squared, and then since we do the square root of, we get the square of both sides, that's the reason when 2a minus the square root of this expression inside, when you express that into square, you apply um, the difference of square, which is that's 2a squared minus twice the product of the a and the b plus the square of your b. I hope you could get that point there. Again, we apply here the identity or the shortcut of x minus y quantity squared. That's what we did there. We simply expand it, and that's the reason we got the right side here. Then to continue, all you need to do is to cancel all those expressions that can be canceled out. For example, x squared is canceled. X squared is canceled here because when you transfer that one here to the left side, that makes us 0. C squared is canceled. Y squared is also canceled on this part. And after that, we still have the remaining expression, which is the 4a squared minus 4a times the square root of x minus c quantity squared plus y squared. So what we did there is just we simply factor out the common. What's the common here? It's actually the 4a, no? So 4a squared minus 4a, and then this expression, the common value there or common term is the 4a. You factor out 4a and you will get it like this. So after factor out 4a, you need to apply there the process and then continuing that. So this explains the reason that the standard equation is not made out from a certain concept, but it is derived from the application of the distance formula. So that's it for the reason why we got the standard equation like that. That's based from, or that is derived from the distance formula. To focus on the definition of terms, we have here the ellipse. As repeated, it's the locus of all points in the plane whose sum, the sum of whose distances from two fixed points, which is f sub 1 and f sub 2, is a constant. The foci are the two fixed points, or two foci, denoted by f sub 1 and f sub 2. The center is the midpoint of the segment between the foci, major axis, and the minor axis. Again, the center is the midpoint of the three foci, major axis, and the minor axis. The principal axis is the line that passes through the foci, which hits the ellipse at exactly 2 points. The vertex is the points of intersection of the axis with the ellipse. Note that there are two vertices. So what are the two vertices? We call it the vertices, and the other one is co-vertices. So we will discover that as we solve certain examples. The major axis is the segment between the vertices, and its length is 2a. The minor axis is the segment whose endpoints are on the ellipse perpendicularly bisecting the major axis, and its length is 2b. And then another axis, another additional term, the segment between the foci has length 2c. We're only talking about the length of the foci. So these concepts here are very important. Students, or to those who are listening right now, these should be mastered. No, we do not just read and memorize them. We should know how to apply the concepts to a certain problem as we solve problems or applications on ellipse. There are two types of ellipse. Number one is the vertical ellipse. It has a standard form situated like this. It's x minus h quantity squared all over b squared plus y minus k squared all over a squared is equal to 1, where hk is the center. In identifying a vertical ellipse, all we need to do is to check the denominator. That's how we do that. The denominator of y variable is greater than the denominator of x variable, and that is a vertical ellipse. Again, as we check the denominator of the standard equation, we can simply identify that it is a vertical ellipse when the denominator of the y variable, which is this, is greater than the x variable. And then if the center is at the origin, we have the x squared all over b squared plus y squared over a squared is equal to 1. It has these following properties. Center is hk, vertices is h comma k plus minus a, co-vertices is h plus minus b comma k, and the foci is h comma k plus minus c. So if you're going to understand the properties of a vertical ellipse, you can observe there that the vertices and the foci are somewhat written alike, but they differ in the letter, which is the A, and the C, because the foci is situated under the vertices, under the principal axis where the vertices will be located and where the foci will also be located. Same observation when we encounter horizontal. As you look at the properties, no, the vertices and the foci somewhat written alike, except by its letter A and the letter C. And in checking or identifying that the given standard equation is a horizontal ellipse, all you need to do is to observe the denominator of our given standard equation. Again, it should be in a standard form before we can say that it is a horizontal or a vertical type of ellipse. So when the denominator of the x variable is greater than the denominator of y variable, there we can say that the given is a horizontal type of ellipse. And that's so far for the key terms and definitions that we need to consider. Let's try to solve or give the coordinates of the foci, vertices, and co-vertices of the ellipse with equation x squared all over 169 plus y squared over 25 is equal to 1. We sketch the graph and include these points. Upon checking our given, as you can see, we have here our denominator 169 and 25. So if you're going to analyze that, which one is bigger? Of course, 169 is a bigger value. We go back to our identification whether it's a vertical or a horizontal type of ellipse. When the denominator of the x variable is greater, then we can say that the given is a horizontal horizontal type of ellipse. So horizontal is already identified. Then you need to recall all those properties needed. But before that, we need to identify the important values. Take note that in finishing or polishing our properties, we need the A, the value of B, and the value of C. So we know that A squared is equal to 169. We also have another given, which is b squared, and that is equal to 25. Also, if you're going to solve for a, that is equal to 13 because the square root of a squared is simply a, and that is 13. And the square root of b squared is equal to 5. So we need to solve for the c. So based from the concept that we have, solving c is simply the square root of a squared minus b squared because the value of our a is always greater than the b. Therefore, to solve for c, we just simply do the square root of a squared minus b squared. And that is equal to the square root of 13 squared is 169, or the given there a squared, minus 25. So if you're going to check and solve that one in the calculator for a while, let me type that in my calculator. That's 169 minus 25. So letter C, or the value of C, is equal to 12. So we already completed the values needed, the A, the B, and the C. Now we can proceed in identifying all the needed properties, the foci, the vertices, and the co-vertices. But we need to identify first what is the center. The center there in the given is actually very obvious because x squared, we have a center 0, or at the origin, because you look at the numerator, that's our x minus h, therefore that's x minus 0. So center is 0, 0. Let's proceed now to the vertices. We all know that the vertices is in a form of h plus minus a comma k. And to apply that, that is simply equal to 0 plus minus 13 comma, the k is 0. And the vertices here is simply equal to positive 13 comma 0 and negative 13 comma 0. So the vertices is already identified. Let's proceed now to our CV is equal to the co-vertices. You need to memorize that it's simply H, comma, K plus minus B, and that is equal to 0, comma, 0 plus minus the value of B there is 5. So as we apply that, that is 0, comma, 5 and 0, negative 5. We already solved our co-vertices. Then for its foci, these are two focus. Take note that was H plus minus C, comma, K. And that is simply 0 plus minus 12, comma, the K is 0. So the 2 points are 12, 0, and negative 12, 0. We already got our needed values. We already have the foci. We solved the vertices and the co-vertices. After that, we're going to sketch the graph needed, and then the graph should carefully be written or drawn but with proper label. And to do that, observe carefully how the graph will look like. So make sure to plot first the center, followed by your vertices, co-vertices, and lastly, you plot also the points of our foci. So you can see it there that it is the V sub 1 for the vertices is located here. This is V sub 1 for the first point, V sub 2, and then our co-vertices is W2 and W1, F1 and F2 are the points of the foci. So in your case, you need to label that one carefully so that we will know that these points that you have located in the Cartesian plane are identified as the vertices, co-vertices, and lastly is the foci. And then you draw your ellipse. You are going to connect the points of your first vertex going to your first co-vertex, going to your second vertex, and then second co-vertex there. And you can see the observation of the graph based on that given. Let's proceed now when the given is a general type or in a general form. So when the given form is in general, take note that the two variables are always being squared. You need to recall the orientation of a horizontal and a vertical ellipse standard equation. So that is our goal. In this case, can we identify directly whether it is a horizontal or a vertical ellipse? So to do that, we just simply need to rearrange them and proceed the process of completing the square. Again, we do the process of completing the square when we convert general to standard equation. So first thing to do is I'm going to rearrange them. That is 9x squared minus 126x plus 16y squared plus 64. Y is equal to 71. I'm going to leave 71 on the right side because even though in our standard form the right side should always be equal to 1, we do that in the later part. What we're going to do is double check first the numeric the numerical coefficient of our variables whether it is equal to 1. So in this case, in the x variable, we factor out there the 9 and then the remaining value will be that is x squared because 9x squared divided by 9 is x squared, and then you also have 126 divided by 9 and that is equal to 14x plus in the y variable we have here 16, so we factor out the 16 and then the remaining would be 9 squared, and then that is 64 divided by 16. We got 4. That's y squared plus 4, close parenthesis, is equal to 71. We're not yet done there. So by completing the square or CTS, that is completing the squares, we're going to work that in each parenthesis inside of the given or of the variables that we have. We start with the x variable. So that is 9, then x squared minus 14x, then you create a blank. So how do you solve that? That is simply b over 2 then squared. So you have it there. That's negative 14 divided by 2 is 7 or negative 7. Squared is 49. After that is the y variable. Then that is y squared plus, I forgot to write the y, there should be y there, y squared plus 4y plus a blank. So that's 4 divided by 2 is 2, 2 squared is 4, is equal to 71. Since we added blanks on the left side, we need to add blank on the right side. You need to make sure that they are equal. Yes, we know that we added 49, but you need to multiply it by 9. So that is 49. 49 times 9 is 441. So you added 441 in the first blank here on the right to make it equal. Also, you have 4 times 16, and we got 64. Again, what we did there is we need to make sure that both sides of the equation should be equal. So that's 49 times 9, we got 441. And then in the y variable, that is 16 times 4, we got 64. Then we do the process carefully. After doing that, that is 9. We express this one into a square, and that is x minus, so what do you think is the value there? So it is x minus 7 quantity squared plus, copy the 16 because we're not yet done, that is y plus 2 quantity squared is equal to, we're going to add that one. So that is 71 plus 441 plus 64, and that's equal to 576. Do you think this is the standard equation? I don't think so, because we need to make sure that the right side should be equal to 1, which means we're going to divide both sides by 576 to make the right side be equal to 1. So there you go. You can use your calculator actually and write 9 over 576. And the answer there is copy. I'm sorry. There you go. You are going to copy the x minus 7 quantity squared all over 64, because 9 over 9 over 576 is 1 over 64. There is still a 1 there, but we don't need to write that. Also, you have 16 divided by 576, and that is, you copy the y plus 2 all over 36. Don't forget the squared. And lastly, that is equal to 1. As you can see, we already form our standard equation, and that is x minus 7 quantity squared all over 64 plus y plus 2 quantity squared all over 36, and that is equal to 1. As you can see, it's in a standard form, and looking at the denominator, the the bigger value, looking at the denominator, is it under the x variable or y variable? Obviously, it is still under the x variable. So that is 64 is bigger than 36. So a squared is equal to 64. B squared is equal to 36. So to find our C, we know that, okay, let me write here on the right side. We know that A is equal to 8, B is equal to 36. I'm sorry, it's 6. Let me erase that one first. Again, let me erase. It's 6. So to continue the process, sir, why is it 8 and why is it 6? Because the square root of 64 in our a squared is 8. The square root of 36 in our b squared is 6. We need to solve for the c. C is equal to the square root of a squared. I'm sorry, I think I erase it all again. So the process there, to continue, I actually erase those points there. Let me continue. A squared is equal to 64, and then b squared is equal to 36. So we solve for the c. We all know that a is equal to 8, b is equal to 6. I erased it accidentally. I'm so sorry for that. You can just recall or go back to the video. Therefore, solving for c is simply a squared minus b squared. So let's substitute there. That is the square root of 64 minus 36. And c, if you're going to type that one in your calculator, that is the square root of 64 minus 36. The answer is, it should be simplified to square root of 7. We already have the value of c. Okay, we're complete already. Again, we have the A, we have the B, and the C. So we can now start our finding of the center, finding of the vertices, finding of the co-vertices, and finding of the foci. So if I could recall that that was x plus 7 again. Again, if I could recall our given there from our standard equation, the center is 7 and negative 2. Therefore, since we all know that it is a horizontal type of ellipse, you can write first the needed properties there. For the vertices, that is h plus minus a comma k. Then the co-vertices is h comma k plus minus b, and the foci is h plus minus c comma k, so that we can substitute the needed values there. Again, the center is the h and the k. The center is the h and the k. So let's make use of the values there. That is 7 plus minus the a is 8 comma, the k is negative 2. Therefore, to simplify that, the 2 points are 7 plus 8 is 15, comma, negative 2, and 7 minus 8 is negative 1, comma, negative 2. These are the 2 points of the vertices. Let's proceed now to the co-vertices. That is 7 plus minus the b, which is the 6, comma, the k is negative 2. I'm sorry, it's the co-vertices already. So I realize that I am writing the vertices formula. That is 7, comma, just the k is negative 2 plus minus the b is 6. So this is how we do that. Bring down the 7, comma, negative 2 plus 6 is 4, and 7, comma, negative 2 minus 6 is negative 8. Therefore, these are the 2 points of the covertices. Now for the foci, the h is 7 plus minus the c, which is 2 square root of 7, or you can write the equivalent decimal. It's up to you. That is still an acceptable answer. Comma, the k is negative 2. And that is simply, you can write that also in your calculator. That is 7 plus 2 square root of 7, the answer is simply write it like that. 7 plus the square root plus 2 square root of 7, comma, negative 2, and the other one is the minus 7 minus 2 square root of 7, comma, negative 2. And we already completed the needed properties, which is the vertices, the co-vertices, and foci. And to plot this one in a graph, it should look like this. Take note to convert our point that has an existing radical symbol, you just simply click the SD in your calculator for the 7 plus 2 squared of 7, that is 12.3 or 12.29. So let's count. So you have it here, the foci is actually located like that. So again, foci number 1 is 7 plus 7 plus 2 square root of 7. The answer is, in my calculator, that is 12. So to check that, so the 12 is here. You can check that one, right? Next is the 7 minus 2 square root of 7. In decimal, that is 1.7. So 1.7 is here. So you need to plot that one as careful as you can, no errors in the plotting. Since it is just estimation, it does not requirely need, sir, do I need to plot it the exact point? As long as it is in between 1 and 2, but almost 2, that's 1.7. Same goes for 12.29, in between 12 and 13, but closer to 12. So that is still an acceptable graph. Make sure to label your point so that it is very clear. We also have another given where we solve, or the given is the foci of an ellipse are the points negative 3, negative 6, and negative 3, negative 2. For any point on the ellipse, the sum, you take note, the sum of its distances, it's just like the definition of ellipse is equal to 4. From the foci is 14. Find the standard equation. So if I am to understand the sum of its distances, that is simply equal to 2a, which is 14. And when you divide that by 2, a is actually identified already, and that is equal to 7. Again, that is equal to 7. Sir, how do we find the B? We don't have idea yet how to find the B, how to find the C. It's just that from the given problem, we are going to write all the needed given so that we can visualize the graph also. Take note that the foci is negative 3, negative 6, negative 3, negative 2. We make use of what? The midpoint formula. Why is it the midpoint? Because based in the definition that the center is simply the midpoint of our two endpoints of the foci. And that is here in the given. So for the midpoint, we know that x sub 1 plus x sub 2 all over 2 and y sub 1 plus y sub 2 all over 2. We substitute the points there. That is simply negative 3 minus negative 3 all over 2 and negative 6 plus 2 all over 2. Negative 3 minus 3 is negative 6 divided by 2, that is negative 3, comma, negative 6 plus 2 is negative 4 divided by 2 is negative 2. So the center is already identified using the midpoint formula, and that is C is equal to negative 3, negative 2. Sir, there is a problem because we already have the A. What we need in the standard equation is the A and the B. We can already write that it is x plus 3 and y plus 2 quantity squared, but we need to solve for the b. And how do we solve the b there? Just simply using our given in this problem. So in analyzing that one, we can solve the value of the c. Sir, how do we solve the value of the c? Take note that the points of the foci involves the c. So we make use of that. So what is the distance of the foci? The distance of the foci is actually 2c. It was in our definition, right? That the length of the foci is equal to 2c. So we use here distance formula. So again, that is the value of our 2c using the distance formula, and that is equal to the square root of, you must remember all those formula. The distance formula is equal to x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And then, sir, where are the points that we're going to use? The points are just here in the given. These are endpoints of an ellipse, right? So we can make use of that. That is the square root of our x. Again, this is x sub 1. That the given x sub 2 is negative 3 minus negative 3 quantity squared plus the y sub 2 is 2 minus 6, or you can just write plus 6 quantity squared. So let us equate that one. So 2c is equal to, you can make use also of your calculator so that to solve it conveniently. And to manually solve that, you need to write it carefully. Again, that is negative 3 minus negative 3. Quantity squared is 0. 0 squared is 0. Plus, that's 2 plus 6 is 8. 8 squared is 64. 0 plus 64 is very obvious, therefore 2c is equal to the square root of 64. And then after that, we need to do the solving of the c. Do you think it is solvable? It is solvable in that case? Yes or no? So in that case, since it is still in a square root of 64, what is the square root of 64? 2c is equal to 8. It's very obvious that square root of 64 is 8. And then we need to make use of the division of 2 because we are solving for the c only. C is equal to 4. We have the A, we have the C. We can now make use of the formula that B is equal to the square root of A squared minus C squared. And that is equal to the square root of 49 minus the 4 squared is 16. So you can make use of your calculator, or that's manually 49 minus 16, and the answer is the square root of 33. B is equal to the square root of 33. So in writing, we are to solve here the standard equation. We have the A, we have the B, and A squared, I'll write comma, A squared is equal to 49, and B squared is equal to 33. We just cancel out the square root there to get the b squared. So in writing that, since this is um, looking at our given, if you're going to plot the given, the A here is greater than the B and the C is 4. Can we identify whether it is a horizontal or a vertical? To check that, you can graph it visually. In my case, I'll just have a small graph and then I'll do estimation only. So the point is negative 3, 1, 2, 3, negative 6, 1, 2, 3, 4, 5, 6, So my point is here, and then negative 3, 2. So that's negative 3, 1, 2. So negative 3, 2 is there. So since the foci, if you're going to connect that, this is the length of the foci. All right, so if you're going to check on this one, since the foci is from up to down, is it vertical or horizontal? Obviously, it is a vertical type of ellipse. So to write that one, that's gonna be x plus 3 quantity squared. You need to remember that a vertical type of ellipse, the denominator is the b squared. That's all over 33 plus, that's y plus 2 quantity squared all over the a squared is 49, and that's equal to 1. Therefore, this is our standard equation of this given, and that's how simple it is. So I hope you take note of those points and the questions that I'm asking. That's very, very important. Lastly, we have here a problem. A tunnel has the shape of a semi-ellipse that is 15 feet high at the center and 36 feet across the base. At most, how high should a passing track be if it is 12 feet wide for it to be able to fit through the tunnel? Round off your answer to two decimal places. In this case, we need to situate the problem carefully. So I actually prepared a graph in this one from my graphing, and then I need to write the illustration. Remember that it is 15 feet high. So you can see this line here, that is the given 15 feet, which is the high at the center. And then, sir, how did you know, sir, that it is standard equation is 0, 0? Obviously, if the center is not identified in the problem, you need to take note. If the center is not stated in the problem, automatically its center is the origin, which is 0, 0. That's how we identify problem. Another one is 36 feet across the base. So if it's 36 feet across the base, that's 18 going to the left and 18 going to the right. If you're going to add to 18, that is 36. It should be equally divided. Negative 18, from 0 to negative 18, that's 18 units. From 0 to 18 is also 18 units. If you're going to add that one, that is 36. The question there, or what is to solve, is at most, how high should a passing track be if it is 12 feet wide? Another given is 12 feet wide of the track. So if the track is 12 feet wide, therefore it passes through the center. If you're gonna ask, it's negative 6 and 6 here because to add the units, that's 12 feet. And that's the reason it's 12 feet wide. For it to be able to fit through the tunnel, so that's the question. At most, how high? I mean, that in the given, that is 15 feet high at the center. Again, that's 15 feet high at the center, 12 feet wide. So we are to solve of this. Remember that the 15 is until here. Again, the 15 is until here. Okay, let me reiterate it again. The 15 is until here because we're talking about the height, and then the point and the point here, this is what we're looking for. It can be referred as x, or it can be referred as the n or the unknown. X is an unknown or n is an unknown. But if you're going to consider the ordered pair, the 6 should be the x, and we're looking for the y in this case. And then to interpret that one, since this is an ellipse, we can say that it is in a 0, 0 center. Its standard form is x squared plus y squared over 18 squared, and the y is over 15 squared is equal to 1. Sir, how did you say that it is 18 squared? Remember that in this type of ellipse, the x there has a denominator of 18 squared. It's because it's 18 units to the left and 18 units to the right. This is only a semi-ellipse. We did not complete yet the ellipse, okay? And also, we have here y squared, which is the y variable, over 15 squared. Why is it over 15? Because it has 15 units of our y located in the y Cartesian plane. 15 units from 0 to 15 of the semi-ellipse form. So if you're going to say, sir, um, if the a is under the x variable and the b is under the y variable, is it gonna be a horizontal type of ellipse? The answer there is yes. Look at the illustration. The form of the ellipse is in horizontal form. It is extended through the x plane, and that's horizontal. So we make use of the standard equation. So to use the standard equation, x squared plus over 18 squared plus y squared over 15 squared, we all know that we have a given x. Sir, what's the given x? That is the 6. So we're going to substitute there 6 squared all over 18 squared plus the y squared all over 15 squared is equal to 1. Again, that's 15 squared, and the y should be the one that we will be solving. So how are we going to do that? First thing to do is you need to identify what is 6 squared. That is 36 all over 18 squared. So using your calculator, that is 36 over 18 squared. The answer is 1 over 9 plus y squared all over 15 squared, which is equal to 1. So how are you going to solve that? We make use of manipulation of equation. Again, we solve for the y here. And how do we do that? That is simply y squared all over 15 squared is equal to 1 minus 36 over 18 squared is 1 over 9. And then after that, you are going to equate 1 minus 1 over 9, which is 8 over 9. So that is y squared all over 15 squared, and that's equal to 8 over 9. So what we're going to do here, since these are two rational expressions from the left and from the right, you can have the cross multiplication. So that's 9 times y squared is equal to 15 squared. You can equate that already. That's 225. 225 times 8. So how much is that one? 225 times 8 is 1,800. So that's 9. Y squared is equal to 1,800. We divide it by 9 on both sides, so we get y squared is equal to 1/8 divided by 9, and we got 200. We're not yet done because we solve for y, we do the square root. So square root of 200, the answer is y is equal to 10 square root of 2. Therefore, we got the 10 there, or in decimal form, that is equivalently 14.14, and that should be in feet. If I could recall, the label there is feet, so the answer should be 14.14 feet, or 10 square root of 2 feet. And that is the final answer. Okay, so that's how we visualize a certain problem, and I hope you learn from this video. Have a good day and enjoy learning Ellipse.